Hello, everyone. I'm Daryl Butt, the Dean of the College of Mines and Earth Sciences, and it's my pleasure to introduce our speaker today for this alumni event. Dr. Jim Steenburgh is a professor of atmospheric sciences at the University of Utah, and he received his BS in meteorology from the Pennsylvania State University and his PhD in atmospheric sciences from the University of Washington. He joined the faculty at the University of Utah in 1995 and has remained with us since then. I'm sure because of the great skiing, but more importantly, because of the great colleagues that he has. Jim's research and teaching interests span mountain weather and climate, mountain and lake effect precipitation, and weather analysis and forecasting. He has published more than 65 peer-reviewed research articles and book chapters. He recently served as a Fulbright Scholar at the University of Innsbruck in Austria and is a fellow of the American Meteorological Society and a recipient of our college's Outstanding Teaching Award, which I consider to be one of the highest honors in our college. Jim's passion for weather and snow is abundantly evident in his book, Secrets of the Greatest Snow on Earth. And this talk is based on that book. I suggest you get a copy if you don't have one already. And it's also based on his blog, Wasatch Weather Weenies, which has garnered more than 3.7 million page views from skiers, snowboarders, and mountain weather lovers. And I have to also add that when I first met Jim, I asked him how many days a year he skis, and he noted very casually about 100, which was about 100 times more days than I had skied that year. So he gets out there and enjoys it. So I hope everybody enjoys this presentation, and thanks for joining us. Jim, it's all yours.
Thanks, Daryl. That 100 is a lie. It's closer to 60 or 70, but it's still a lot, although a lot of it's cross-country skiing these days. Give me just a second here to share my screen. And hopefully we are off and ready to go. And let's be talking about secrets of the greatest snow on Earth. And this is a talk I really love giving in the fall when people are really getting excited about snow and the upcoming ski season. And there's a lot of reasons to be excited about the upcoming ski season. That word upcoming doesn't even apply this year. I've already had 3 days of skiing in, and people have been getting out because we're off to a really good start to the ski season here in Utah. It's probably, the records at Alta are spotty when you go way back in time, but since about the mid 1940s, it's probably the 10th best October that we've seen. So really exciting ski season. But I'm here to talk to you about the secrets of the greatest snow on Earth. This talk's based on my book. And kind of the motivation for this book was all the questions that I used to get about Utah skiing and is our snow really the greatest on Earth? So let's delve in here a little bit into what the secrets of the greatest snow on Earth are. And when I wrote the book, one of the things I wanted to do was include a history of the greatest snow on Earth phrase. And it turns out it wasn't easy to find the answers to that. There had been a lawsuit between the Ringling Brothers and Barnum and Bailey Circus. They sued the state of Utah over that slogan. Eventually, the state of Utah won. But when I went through the court records, I couldn't find an answer of exactly where the phrase came from. But I had an ace in the hole, and that ace in the hole was a guy named Dave Hanscom. Dave is really a legend in the Nordic and backcountry community here in Salt Lake City and in the Wasatch Range. And so I called him up one day and said, well, do you know where the phrase came from? And he told me he didn't, but a guy named Mike Karolagos did. And I was all done with my book except for that section. And I'd been putting off calling Mike because, like many academics, I'm not the best at cold calling. And I just happened to be at a show at the National History Museum. There were about 1,000 people there, and who was standing next to me but a guy with a name tag that said Mike Karolagos. So I struck up a conversation with him and asked him, Mike, where did the phrase greatest snow on Earth come from? And he said, oh, my brother invented it. And I got a pretty good laugh out of that. Oh, yeah, my brother invented it. Turns out his brother is Tom Karolagos, and he's a pretty impeachable person. He's been a U.S. ambassador. He's helped about 300 people get through Senate confirmations. Very impressive background. So I called up Tom and talked to him, and he said, yeah, I used to write for the Salt Lake Tribune, and I think there was an article in 1959 or 1960 the Ringling Brothers and Barnum and Bailey Circus had been in town. And I thought, oh, greatest show on earth, greatest snow on earth. Wouldn't that be great? So I spent a great deal of time going through the microfilm at the Marriott Library. And after a long, hard look and a lot of hardcore work every morning, I found it finally. This is the first use of the phrase greatest snow on earth that I can find in the published literature. It's an article written by Tom Korologos for the Salt Lake Tribune Home Magazine, December 4th, 1960. And you can see this phrase, greatest snow on earth, here being used. And in the article, Tom writes, Intermountain folk will tell you that the winds blowing from the west leave the wet, sticky snows in the Sierras. When the storms reach the Intermountain ranges, only the most perfect dry powder is left. And he goes on to describe the Intermountain region and then concludes with, that's the extent of the Intermountain's big top, which supports this real, true greatest snow on earth. And with that article, I believe the legend of Utah skiing was truly born. Now, conventional wisdom about whether Utah's snow is the greatest snow on earth or not are statements like these. And I got these out of like Ski Magazine, Potter Magazine, etc. So one of these statements reads, the greatest snow on earth is more than a catchy slogan. It is a scientific fact that Utah's snow is lighter and drier. Or because of the high salt content of the lake, storm clouds create a unique type of snow that is particularly light and dry. Experts call it the lightest, driest snow anywhere. Well, we have a name for phrases like this in the science community, and it's called BS. There's none of this is true. Most of this is all made up, and there's no scientific evidence of these things. In fact, what's interesting, one of the dirty little secrets of Utah snow is the snow here is not actually exceptionally dry. If you look at the average water content of snow in the continental United States, yes, you see it's typically higher in the Pacific ranges, and it decreases as you move downstream of the Cascades and the Sierras, but it continues to decrease as you move into Colorado, Wyoming, and Montana. So on average, the snow in a good chunk of Colorado, Wyoming, and Montana is drier than it is in Utah. And in fact, if you go to the UP, the Upper Peninsula of Michigan, and some of the areas around the Great Lakes, they get snow that on average is as dry or drier than what we get here in Utah. So Utah snow is not unusually dry. On the other hand, the reality is that the best powder skiing is not found in the driest snow. And I like to use this quote from Ed LaChapelle. Ed LaChapelle was a famous avalanche researcher. He worked in Little Cottonwood Canyon for quite a while, was a snow ranger up there. And in 1962, he wrote, the best deep powder skiing is not found in the lightest snow, but rather in snow with enough body to provide good flotation for the running ski. And that body is provided by snowstorms that produce higher density snow to start and lower density snow to finish. That's the optimal so-called stacking of the new snow to provide great powder skiing. And it's my experience that that is the best powder skiing. That's what I look for when I am thinking about having a great powder day. So the secrets of the greatest snow on earth are, number one, that we get abundant snowfall. Colorado does get drier snow, but it doesn't snow anywhere near as much in the Colorado mountains as it does in the Wasatch. So a place like Alta averages over 500 inches of snow a year. So we get abundant snowfall. We get lots of what I call Goldilocks storms. These are storms that are not too big and they're not too small, but they're just right for deep powder skiing. Good deep powder skiing really starts with a fresh snow depth of about 10 inches. And it starts to become problematic, especially for avalanche conditions when snowfalls become behemoth. A place like the Sierras, for example, that's famous for these enormous snowfalls. A lot of those big dumps, you think, 40 inches of snow, that's got to be great skiing, but it's really kind of overrated. And oftentimes it's very dangerous to get out on terrain that's steep enough to ski on. So you really want a lot of Goldilocks storms. And Alta averages about 18 days per year with 10 inches of snow or more. And that's a very high frequency of deep powder days. And finally, you want a climatology, kind of a storm track characteristics or characteristics of storms that favor lots of this right side up hero snow. This is snow with the right body to provide good flotation for the running ski. So those are the three things that I like to mention are the real keys or the real secrets of the greatest snow on earth. Well, there are a few other dirty little secrets, and that is, not all of Utah is blessed with that kind of snow characteristics. So I want to talk a little bit about Wasatch microclimates and what we find here around Utah. And astute Utah skiers are well aware of some of these facts and observations. But I want to give a nod first to another meteorologist. In 1935, and in the 1930s, there was a meteorologist in the U.S. Weather Bureau, the predecessor for the National Weather Service, by the name of S.D. Green. And he was a backcountry skier. And in the 1930s, the original Utah interconnect involved taking a train or getting up to Park City somehow, and then skiing up and over and into Brighton Basin, where Brighton Ski Area is in upper Big Cottonwood Canyon today. And in 1935, S.D. Green took this photo of Brighton Basin that you see before you. Beautiful day, probably a great powder day. You can see the skin track here where the skiers are working their way through Brighton Basin. And in 1935, S.D. Green wrote, "Skiers will eventually find that the heads of the Cottonwood Canyons offer the best skiing to be found in the Wasatch Mountains." So even in the 1930s, people were getting clued into the reality that the Cottonwoods are kind of the epicenter for great powder skiing. And of course, we've seen that play out very well over the last few decades. So the map you see before you is a map of average annual snowfall in the central Wasatch and then in the broader Wasatch Range as a whole. And so here's the central Wasatch with Big Cottonwood Canyon, Little Cottonwood Canyon in the Park City area. And you can see here how blessed that Little Cottonwood is, in particular, the high terrain flanking Little Cottonwood Canyon, the Alpine Ridge, and then the high ridge that separates Big Cottonwood Canyon, from Little Cottonwood Canyon. And these are the areas of the Wasatch that get more than 500 inches of snow a year on average. By the time you get to the Park City Ridge line, snowfall drops off. And at the very top of the Park City Ridge line at elevations around 10,000 feet, it's more of around 400 inches a year. And then it decreases even more as you move down into the Park City proper area. So this area around Little Cottonwood Canyon is really what Utah's powder reputation is based on. Now, if you look at this map for the northern Wasatch, though, I like to point out that there's a place up here, just north of Ogden, known as Ben Lomond Peak, on of snow. And we'll talk about that in just a minute and what happens up there. And it's kind of my secret spot, so to speak, or maybe not so secret spot at this point, for very heavy snowfall in northern Utah. Also, the North Ogden Valley here, where the North Fork Park cross-country center is, that's operated by Ogden Nordic, is also, for its elevation, an extremely snowy place, a very good place to cross-country ski if you like to do that. Well, what's so special about the Cottonwood Canyons? It's the first question that people get, and there's a lot of myths about this. I like to think about this problem somewhat three-dimensionally. When you think about the Wasatch Range, it runs predominantly from north to south, but in the central mountains southeast of Salt Lake City, there are major ridges that run east-west. And what that does is it kind of broadens, it makes the Wasatch wider, but this terrain is also very high. These ridges are close to 11,000 feet or even over 11,000 feet in a few places. And this creates an island of high topography that's exposed to the flow from virtually any direction. In the meteorological business, we talk about something called orographic lift, which is lift from flow interacting with terrain. So when the flow comes into the terrain, like water flowing towards a rock, it has to rise up and over it. And when air is forced up, it cools. And as a result, it can lead to condensation and precipitation production. So this area around the Cottonwoods, whether the flow is from the southwest or from the northwest, or even from the southeast in some situations, gets a decent amount of snow. It gets the largest variety of storms anywhere in northern Utah. And that's the main reason why it snows so much in the Cottonwood Canyons. There is some lake effect that helps as well. That produces about 5 or 6% of the total snowfall in the Cottonwoods. But even if you took the lake out, this would still be the snowiest place in the central Wasatch. Now, Ben Lomond Peak is an interesting situation because the northern Wasatch around Ogden are much more linear. They run very straight and they're very narrow. And this is a view looking to the south. So you can see the Wasatch Mountains here. Snow Basin would be located right about in here. So the Wasatch Range is running to the north. And then when you get up by Ben Lomond, all of a sudden the mountains jut to the west a little bit. And what this does is it creates a terrain concavity. And these terrain concavities are known to enhance precipitation. And so lots of times we get the funneling of the flow into this terrain concavity that gets forced up and over the area around Ben Lomond and produces very, very heavy snowfall that sometimes spills over into the Ogden Valley, which is one of the reasons why the Ogden Valley is so snowy. Now, I like to tell people that Ben Lomond Peak is kind of like a boxer. You know, boxers, people like to say that someone is pound for pound the toughest or the best boxer in the world. That usually involves somebody that's a middleweight or something like that. And the argument is maybe they can't beat a heavyweight, but they're the best boxer for their weight. And Ben Lomond Peak is kind of like that. At its elevation, it's the snowiest place in the Wasatch Mountains. So Ben Lomond Peak, there's a SNOTEL station. These are automated snow measurement stations that have been put out by the US government to help measure water in the snowpack and snow depth. There's one on Ben Lomond Peak that's just under 8,000 feet elevation. And the snowpack there is oftentimes very similar to what it is at Alta at their Collins observing site at 9,700 feet, which is 1,700 feet higher. And I oftentimes take students up here, up to Ben Lomond in the spring, because they are doubtful of how much it snows up there. And one year, this was in 2005, I made my students dig a full pit profile on April 26th. And you can see me here in the snowpack here. There's 13 feet of snow, 156 inches. On the same day at Alta, there was just a bit more at 165 inches, even though it's 1,700 feet higher. So this area around Ben Lomond is probably pound for pound the snowiest place in the Wasatch Range. Now, a couple things on about what happens in the Park City side. You know, Park City is oftentimes downstream of the Wasatch Range during winter storms. So when the flow is out of the southwest or out of the west or out of the northwest, Park City is, especially the city itself, is oftentimes in what meteorologists call a rain shadow or a precipitation shadow, or you could call it the snow shadow on a winter storm. This is the low precipitation area downstream of a mountain range. So Park City survives to a large degree on what we call spillover. This is precipitation or snowfall that's carried downstream into the lee of a mountain range. And this is a photo I took of this spillover where there's a lot of snowfall that's falling near the Wasatch Crest. Some of it is getting carried downstream, and then there's a very pronounced precipitation shadow over Park City. Now, in winter storms, oftentimes it's not clear. It's still snowing in Park City, but the amount of snowfall is lower than what you would find near the Wasatch Crest or in the Cottonwoods. If you're looking for big storms in the Park City area, what you want to do are look for storms where the Wasatch back becomes temporarily the windward side of the Wasatch. And these are storms that are characterized by, instead of, say, southwesterly or westerly or northwesterly flow, they're characterized by southeasterly or easterly flow, because that temporarily shifts the windward side of the Wasatch from the Salt Lake Valley side to the Park City side. And these are some of the largest storms that you find at Park City Mountain Resort, at Deer Valley, and along the Park City ridgeline. Let's shift gears and talk a little bit about beyond Utah. A lot of people ask me where they should take their ski vacations or when. And I'm going to talk a little bit about some of my favorite snow climates here all around the world. And first and foremost, I spent 5.5 years in the Cascade Mountains of Washington. And it was a great place to live and to ski, because it just snows so much in that part of the world. And, you know, the world record for snowfall during a season is held by Mount Baker Ski Area, which is in the North Cascades on a large volcano, actually at lower elevations on that volcano, somewhere between about 4,000 and 5,500 feet. And in the 1998 to 99 ski season, they recorded 1,140 inches of snow, which is the world record for any measurement site on Earth. There are probably places in the world that get more snow than this. For example, in the Olympic Mountains of Washington and some of the coastal ranges of British Columbia and Alaska, if there was anybody up there measuring the snow, they would probably see numbers bigger than this. But for any measurement site on world, this is the all-time world record. And this is a photo that they took late that season of an extremely deep snowpack. I'm a huge fan of the Great Lakes snow belts, in part because I grew up in the Southern Adirondacks right about here. And I used to ski some on the Tug Hill Plateau and in the Western Adirondacks in the so-called snow belts that you see identified here downstream of the Great Lakes. And these storms are unique. They do produce skiing on some of the smaller hills and upland areas that exist in those areas. But what they're most known for is intensity. So the most intense snowstorms on Earth happen downstream, especially of Lake Ontario. Most of the world record snowfall accumulations in short periods of time have happened on downstream of Lake Ontario. And we did a field program a few years ago on the Tug Hill Plateau, and we observed 4 storms that had peak snowfall rates of over 4 inches an hour. So this is a place where it dumps, and it dumps hard. And one of my graduate students at the time was a former Alta ski patroller, and she told me she never saw it snow at Alta as hard as it does on the Tug Hill Plateau. So it's really intense snowfall that you get in this part of the world. Of course, the Alps are famous for skiing. They're the birthplace of skiing, and I get a lot of questions about snowfall in the Alps, and I was really lucky to spend my sabbatical a couple of years ago at Innsbruck, which is in the Inn Valley here in Western Austria and Austria's Tyrol. And the Alps are really kind of a unique meteorological range because they're so high and they're so broad. And what you're seeing here is a map of the average annual rainfall. So this is precipitation, basically a combination of rainfall plus the water equivalent of snowfall. And this is one of the tricks of finding snow in the Alps, is to recognize that the wettest places in the Alps are actually on the rims of the Alps, the so-called North Rim and the so-called South Rim. And finding high elevation areas along in the kind of the Alpine North Rim and the Alpine South Rim is the key to finding places that get lots of snow. A lot of high altitude resorts, like say Zermatt, it's actually, even though they have snow cover there all year long, Zermatt operates skiing on their upper mountain all year long. It's not because it snows a lot during the winter season. It's because they have a very long snow accumulation season, and it's cold there most of the year because of altitude. The snowiest places in the Alps are the high altitude areas on these rims. And one in particular would be the Arlberg area and the ski areas that include Vart and Lech and Surs and St. Anton, this area here in the Arlberg that's on the northern rim and at relatively high elevations and has probably the most snowfall during the winter months anywhere in the Alps, and one of the more reliable snowpacks in that part of the world. Another place that's kind of snowy and has a fairly reliable snowpack is a place like Andermatt in Switzerland. And an interesting part there is that's an area where the Alps get relatively narrow. And so there's a tendency to get storms from kind of the south and the northwest and the north there. So they have a little bit greater storm variety than you find on the rims. So that's a little bit of talking on the Alps. Now, my favorite snow climate is the snow climate of Japan. And really, Japan is the most unbelievable place in the world for snow, as far as I'm concerned. Because what happens in Japan is it lies downstream of the biggest continent on Earth. So that's Eurasia, combination of Europe and Asia. And during the winter, during what they call the winter monsoon, there are frequent cold air outbreaks that occur off the massive continent of Asia. That's where the coldest air is found. And it moves over the Sea of Japan, which is this massive body of water that's 12 times bigger than Lake Superior, the largest Great Lakes. And that flow, basically, the cold air moving over the Sea of Japan produces sea effect snowfall, very similar to lake effect snowfall, that then runs into the high terrain of Honshu and Hokkaido. And Hokkaido in particular is known for drier snow than Honshu, although the mountains on Honshu, especially in the Haida Mountains near the Sea of Japan, are much bigger and steeper. But Hokkaido is known for drier powder, and their snow climate there is pretty incredible. I'm going to do a quick comparison here of data from Alta. This will be the average monthly snowfall at Alta, which are these blue bars. compared to the average monthly snowfall in Kuchen, which is these red bars. And what you see here is that Alta basically has a fairly long snow accumulation season that picks up in October and November, and then December, January, February, March, those 4 months average just around 80 inches a month or just under. And if you divide by the number of days, the amount of snow per day from about December through March is very consistent, and even into early April, very consistent at Alta. On the other hand, at Kuchen, and this is a pretty low elevation site, 590 feet above sea level, they have an extremely peaked snow accumulation season, virtually no snow at all in October, and then an incredible maximum in January. Kuchen averages almost 150 inches of snow, nearly double Alta during the month of January. So the surest bet for deep powder skiing anywhere in the world is in Japan in late January. The 90% of the Januaries in Kuchen average or observed more than 100 inches of snow. So this is an incredible place. And Sapporo is the snowiest city in the world with a population of over 1 million people. So very, very snowy. And if you go into the Hakata Mountains here, there's an observing site there, Sukayu Onsen, that averages, I believe, 694 inches of snow a year. I believe it's the snowiest observing site and inhabited location anywhere on Earth. Pretty amazing stuff. All right, shifting gears a little bit now and getting into something a little more interesting and with a little more science too, maybe in terms of cutting into stuff besides atmospheric sciences. I want to talk a little bit about what happens in Little Cottonwood Canyon on a powder day. And I like to call this Alta goes to war, because there's a lot of explosives that are used to make Little Cottonwood a safe place. It's good to do a little bit of a history lesson here. Alta in the late 1800s was a place where mining occurred. And it's an extremely dangerous place today if Mother Nature is left to her own devices. And it was an extremely dangerous place in the late 1800s when mining occurred. This is a photo I obtained from the Utah State Historical Society, looking south, probably from about where the town of Alta is today, at where Alta ski area is. So this photo that you see here is of what today is Alta ski area, taken on the 3rd of July, 1885. Must have been a big snow year, and it was cooler than we see today. Still a lot of snow on the ground. You can see a lot of devastation in the town of Alta from avalanches that year, which may have actually come down from the north side of the highway, just looking at the damage here. And just to kind of orient you, this is where the famous run High Rustler is, sometimes called High Boy today. This is Mount Baldy up here, so this is Collins Gulch. Albion Basin is to the left. This is the Eagle's Nest area. What you'll notice is there isn't a single tree that exists in that area at that time. Everything that we see today where there are trees is because efforts have been undertaken to revegetate Alta ski area. It also, because of all this deforestation, increased the avalanche hazard. Trees are very important for anchoring snowpack. And so little wonder that there were a lot of avalanche fatalities, plus all the terrain around Little Cottonwood is avalanche terrain. Now, the number of people that were killed in snowslides during the mining era is somewhat up for debate. But in 1884, the Salt Lake Tribune wrote that since mines at Alta were first opened 14 years ago, 143 people have been killed by snowslides. I've seen lower numbers, under 100, but certainly this tells us that Alta is a very dangerous place if Mother Nature's left to her own devices. Now, eventually powder replaced silver and people started going to Alta to ski. And, today, there are a lot of ravenous powder skiers out there lining up at the bottom of Little Cottonwood Canyon to go powder skiing. But believe me, even if you go back through the records, there were people that loved to ski powder right from the day that they first started putting lifts in at Alta. This is a quote from Forest Service Supervisor Felix Koziol in 1946. Winter skiers wander all over the landscape. Many are not content to stay on the practice slopes and on the ski runs close to the lifts. An increasing number are seeking ways of getting far out into the alpine hinterlands, far away from the snow bunny crowd. So even back in the 40s, people were at Alta to ski powder. And as a result, people wanted to get up the canyon. people wanted to go skiing. And in the 1940s, Alta began to employ a series of snow rangers. And eventually, one of those snow rangers was a fellow by the name of Monty Atwater. He was a 10th Mountain Division veteran and had experiences with explosives. And he began to use artillery to try to tame the beast, the avalanche beast in Little Cottonwood Canyon. And this is a photo taken by Ed LaChapelle, another famous avalanche researcher, of Monty Atwater with a French howitzer in Upper Little Cottonwood Canyon in the 1950s, obtained from the Marriott Library. So let's talk a little bit about Little Cottonwood Canyon today. Little Cottonwood Canyon has the highest avalanche hazard index of any highway in North America, and that's based on exposure to avalanches and also vehicular traffic. So 7,000 cars per day or so during the winter months travel beneath 50 avalanche paths as they ascend and descend Little Cottonwood Canyon. And State Route 210, the main highway that goes up Little Cottonwood Canyon, is hit by an average of 33 avalanches per year, typically when the road is closed, but not always. And Alta is the only place, and Steenburgh, the only place in the United States where live artillery is shot over the heads of civilians, although that's changing, and we're getting very close to being able to avoid that in the near future. And in the 1980s, there was a study done by some folks here at the University of Utah estimating a day of closure in Little Cottonwood Canyon was a loss of revenue of about $1 million a day. If you convert that to current dollars, it's about $2.5 million a day. So I'm using that number here, although I admit it's somewhat uncertain. But when there are real economic losses when the canyon closes, not to mention a lot of very disappointed and upset skiers at the bottom of the canyon, but also a lot of very happy skiers at the top of the canyon if the resorts can get going and they can enjoy what's called a country club day, where they have the resorts to themselves. This is a picture of the 50 avalanche paths, or an image of the 50 avalanche paths that intersect State Route 210. So you get an idea that as you drive up from lower Little Cottonwood Canyon up to Snowbird and Alta, that you're just passing one avalanche path after another. Not all of these avalanche paths run every year to the highway, but potentially they can. And of course, this doesn't include all the avalanche paths that affect Alta and Snowbird ski area and also have to be dealt with from an avalanche mitigation perspective. Now there's, like I mentioned, a whole ton of artillery that's used in Little Cottonwood Canyon to try to mitigate avalanche danger. There are 205 millimeter howitzers. These are large military weapons that are used to fire 105 millimeter shells across the canyon and basically trigger avalanches that come down and reduce the avalanche hazard. This is done, of course, when the road is closed. Avalanchers, which fire smaller 2-pound charges. You may notice if you look on the north side of the highway now, a number of these gas exploders above Snowbird. And these have, I believe it's a propane that they light, and it creates an explosion that gets directed down onto the snowpack from this pipe. And then above the town of Alta, over the last couple of years, they've been installing these VSIN towers. And these towers have charges inside of them, and they can be remote detonated. And what happens is the charge gets lowered from the tower, and then it goes off over the snowpack to trigger the avalanche. These GASX exploders and these VSIN towers are being put in part to limit the number of shells that are being used and launched by these howitzers. And the idea there is to create greater safety for the folks that are in Snowbird and Alta in case there was an errant shell or something else that happened. Let's just take a look at what this would look like on a day, maybe certainly when the road is closed and UDOT is shooting avalanches above the highway. I'm going to show a video here using either night vision or thermal vision. I'm not sure which it is here, seen from the Peruvian Ridge howitzer at Alta. This is looking at Mount Superior, which is the famous mountain that you look at often from Alta and Snowbird, very picturesque. And keep an eye out just below this arrow. You will see eventually when I start this video, the charge or the explosion here when the shell hits the snowpack, and then what happens. So let me go ahead and start that. Nope.
Then front, then rear, All clear. Ready, fire. Fire. Shot 8 feet.
So now the shell is flying across Little Cottonwood Canyon, and eventually it'll impact just below that arrow on Mount Superior, boom, and you can see how it immediately
Yeah.
triggers a
Awesome.
large avalanche that
Very
then
nice
Nice
Wonder why.
propagation, like a
Yes.
V, downhill V.
cascades down the hill. The idea here is to release that snowpack while the road is closed and before it becomes very dangerous for buildings and other structures that are in Upper Little Cottonwood Canyon. So the idea here is to produce smaller avalanches that are controlled rather than behemoth large avalanches. And there you can see the avalanche working its way down down Mount Superior. Of course, we still have a situation where cars and other vehicles occasionally get hit by avalanches. It's not a perfect science. Maybe every year or two, a car will get hit. And this just happens to be an example from 1988 of a UTA bus that was involved, hit by an avalanche in Little Cottonwood Canyon. So this is a really important forecast problem for ski area operations and for safety on the highway. It's something that I'm quite interested in, and I do quite a bit of research to try to improve both computer modeling and the techniques we use with those computer models to provide better forecasts of snowfall, wind, and temperature in the canyon. I'm going to conclude with a little bit of talk about global warming. Oftentimes I skip this when I give public talks because I don't like to end on a downer, but I know there's a lot of questions about climate change and how it's affecting skiing in Utah and around the world. So I'm going to hit a few highlights here. And of course, the planet is warming, and this is a record of the globally average temperature since 1880. So since the instrumented record became somewhat reliable. And it's the departure from average. So these areas in blue would mean that these bars in blue would mean that the globally average temperature is below the 20th century average. And then as you go forward in time and you get more of these reds, these are years where the globally average temperature is above the 20th century average. So you can see this warming that has occurred over time. And we currently are running in recent years almost a degree Celsius or 1.8 degrees Fahrenheit above the 20th century average temperature for the globe. And nowadays, the conclusion of the Intergovernmental Panel on Climate Change is that it's unequivocal that human influences warm the atmosphere, ocean, and land. Widespread and rapid changes in the atmosphere, ocean, cryosphere, and biosphere has occurred. So this warming, especially since 1945, is driven largely by human influence, especially the increase in greenhouse gases in the atmosphere due to human activity. Now, amongst the impacts, probably the most obvious impacts that many people are aware of are the impacts on glaciers. And this is just one example from the Utztal Alps in the Tyrol of Austria, just showing the retreat of glaciers. Now, this retreat began, after the end of the Little Ice Age, and part of it was natural. But since 1990, or since the 1990s, the main driver of the global retreat of glaciers has been the human-caused climate change. So the shrinkage that we have seen and the retreat of glaciers pretty much all around the world, with one or two very localized regional exceptions, is driven largely by global warming. And this is becoming a threat to skiing in the Alps. In particular, you have some ski resorts that operate year-round, like Hintertux, for example, in Austria, critical training ground for skiers, for example. And that's going to become more difficult as we move through the next few decades. What's been happening in the Western US? Here's a chart back to 1895. Again, these are departures from the 1901 to 2000 average, so the 20th century average. And you can see through about 1985, the ups and downs that we have seen in temperatures. I didn't check to see if this is winter. I'm not sure if this is wintertime or annual. Apologies that I forgot to write that down. But you can see these fluctuations up and down and up and down. And we have not had I believe maybe this is a year in the Western United States with an average temperature below the 20th century average since 1993. So we have seen this shift, this loading of the dice to warmer years and warmer winters over the last 3 decades in particular. And so a cold winter today is not a cold winter from the middle of the 20th century. I oftentimes tell people that the climate system we live in today is not our grandparents' climate system. We have seen this shift to warmer temperatures, and it has had an impact on snowfall and on snowpack. Now, these are trends in 1st of April, so kind of the end of the snow accumulation season. The water equivalent of the snowpack, how much water is in the snowpack divided by how much precipitation fell since October 1st. And this is kind of a good way to look at snowpack trends. It's a measure of how much of the wintertime precipitation is retained in the snowpack at the end of the snow accumulation season. So it integrates across issues like how much precipitation is falling as rain instead of snow, melt events, and that sort of thing. And I like to tell people that global warming, when it comes to snowfall and snowpack, is not an equal opportunity offender. It has a bigger impact on snowfall and snowpack in warmer or lower elevation areas than in upper elevation areas. And that's what you're seeing here. Again, this is only through the end of the 21st century. You can see declines in snowpack in the lower elevation areas, especially below about 6,200 feet. And then as you move to the higher elevations, those trends flatten out. And so the impacts of climate change in the latter part of the 20th century were really maximized in the lower elevations. These trends are continuing. The losses of snowfall and snowpack in the lower elevations in general are greater than they are in the upper elevations. There's a positive aspect of that in that places like Alta and Steenburgh, which are above 8,000 feet, they have some insurance against the initial wave of global warming. Most of their precipitation today during the wintertime still falls as snow. They have north-facing terrain. Snow melt events and rain on snow events are less common there than you find, say, at Park City. And with warming, the transition to rain on snow events and losses to snow are going to be more frequent and more substantial, say, at the base at Park City than at the base of Alta. So to quickly summarize what we've been seeing, this is from our National Climate Assessment in 2018. Declines have been observed in that North American spring snow cover, extent and maximum snow depth, as well as snow water equivalent, which is a measure of the amount of water stored in the snowpack in the Western United States. Here's an example of kind of the impacts with elevation. This is a study that was done by Lee Sturgis in my department, looking at the fraction of precipitation that previously fell as snow in the late 20th century that would instead fall as rain with a 1 degree Celsius, 2 degrees Celsius, 3 degrees Celsius, and 4 degrees Celsius of warming. So you can see with a 1 degree increase of temperatures, not a huge change. But when we get to 2 degrees Celsius, 3 degrees Celsius, 4 degrees Celsius, there are very large losses of precipitation that previously fell as snow that would instead fall as rain in the lower elevations, over 50% in some areas. So, but if you look at the highest elevations, the losses are still fairly small. So in Utah, what we're seeing and what we expect to see is that the impacts on snowpack and snowfall in the wintertime are going to be especially strong in the lower elevations. This is going to make the hollowed ground that is the Cottonwood Canyons even more hollowed moving forward, because this is going to be an island that there's still going to be climate change impacts on. There will be more rain on snow events. There will be more mid-season snowpack loss events, but these are the last places where the last good skiing is going to survive. So 20th century expectations are an acceleration of warming, this loading of the dice for warm winters and years. It doesn't mean we couldn't have a cold snow year. We couldn't have some good snow years, but we're seeing this loading of the dice for warmer winters. We're going to see a decreasing fraction of winter precipitation falling as snow. So we're going to see more rain instead of snow falling. We're already seeing this in the lower elevations. We're going to see a decreasing fraction of winter precipitation retained in the snowpack at the end of the snow accumulation season. This is due to the snowfall, the transition to rain, but also more mid-season snowpack loss events. But the size of these declines depends on what we do today. We cannot mitigate, or we cannot prevent the global warming that's going to happen in the next 2 decades, maybe even the next 3. That's already in the pipeline, but what happens beyond that depends a lot on future greenhouse gas emissions. So with that, I'm going to wrap up and thank everybody for your attention today. I really appreciate it. I wish we could all be together in person, maybe better yet, up at Alta enjoying the snow today. But thank you, and I'll be happy to take some questions. I believe Daryl has some that were sent in previously from the audience.
Thank you, Jim. That was fantastic. I'm not sure how the questions come to us. I think they come through chat, maybe. I do have a few that I'm going to go ahead and ask, and if I see other questions pop up, I'll ask those as well. And really enjoyed that, Jim. I have a feeling I'll be shopping for alpine skis this weekend because it kind of got me psyched. That was fun. First question I have is, could you talk a little bit about careers in atmospheric sciences? I'm sure we have maybe some young folks out there and maybe some parents or grandparents that would be interested too.
Yeah, absolutely. I can't remember, the U.S. Bureau of Labor and Statistics did a study projecting future trends in employment, and atmospheric sciences was one of the highest ones over the next decade by 2030. I think it was a 16% growth rate. The atmospheric sciences jobs are in really 3 areas. Government is one, private sector is another, academia and research is a third. We're a small profession. For example, the American Meteorological Society has 10,000 members, but it's extremely rewarding field to be in. The one thing I like to tell people is, forecasting is still done, but most of the jobs in meteorology are not forecasting jobs. They're maybe related to weather instrumentation management, developing computer models for forecasting the weather, developing machine learning models for forecasting the weather. The most growth that I have seen where my students are getting jobs are in the private sector today. I have a former PhD student who works at Amazon, for example. Drone weather forecasting is a really important thing. So it's a pretty exciting field to be in. I think it's pretty rewarding. And of course, climate and providing good guidance to people for planning for climate change is also a growth area, become more important during the 21st century.
Jim, could you say a little bit about the different fields or areas of research in your department, the Department of Atmospheric Sciences, some of the things that your faculty do generally?
Yeah, we work on a lot of things. Personally, my work is on mountain weather and climate, focusing on precipitation, especially snowfall. So trying to improve understanding of mountain snowstorms and lake and sea effect storms, where we're kind of trying to understand what makes them tick, understanding the physics, understanding the mechanisms that drive them, and then improving the computer modeling of them and the forecasting of these storms. But we have other people that work in, say, regional climate modeling, trying to understand how snow and runoff are going to change in the future or are changing now. And they may be doing regional climate modeling to do that in places like Utah and high mountain Asia, for example. We have people that work on snowfall measurement, like microphysics of snow, like details of what's going on, observing it at high, and so there's that going on. We have people trying to understand. A real challenge in climate prediction is the feedback of clouds and how clouds are going to change with climate change. That's a critical area, and we have a large group working on that as well. People working on air quality, air chemistry here in the Salt Lake Valley, aerosols, pollution, and how it gets transported around the globe. So we kind of run the full gamut, and a lot of the research we do is very practical, and it affects, I always like to think about it good weather forecasts are good for everybody. Good air quality forecasts help us to mitigate air quality problems, those sorts of things. So it's a fun field to be in.
So what's the forecast for skiing this year, and how do you forecast that far out?
Well, my usual comment to that is we don't know what the heck is going to happen in northern Utah. The Wasatch Range is a funny place because our weather doesn't correlate very well with, say, things like El Nino and La Nina. When we're talking about predicting what's going to happen for a season, the atmosphere by itself is not really predictable more than a week or two in advance with very much skill, very much reliability. So we have to rely on the oceans, which evolve more slowly. kind of forecast seasonally. So for instance, when an El Nino occurs, the warming of the Pacific Ocean in the central and eastern Pacific shifts where thunderstorms occur on the equator, and that in turn affects the jet stream. So El Nino years, not all of them, but a lot of them kind of load the dice for the Southwest to be wetter and for the Northwest to be drier and warmer. La Nina years kind of load the dice for the Southwest to be drier and the Northwest to have a good ski season. It's not perfect correlation, but that's there. And that's one of the key things we do to predict the seasonal weather. But northern Utah sits right on that transition zone. So it's one of those things where I think the fact we're off to a good start now, that's, we already have 50 inches in there in some areas. That's a good start and that helps. But I don't know exactly how the season's going to play out. My usual line is, ski it if it's white, if it snows, go skiing and don't worry about it. And a bad year here is better than a good year in Colorado. So you're living in the right place here in Utah.
So does pollution in the valley affect the skiing at Alta or Snowbird or particles in the atmosphere?
The thing that has the biggest impact on skiing at Alta is dust. Mm-hmm. And if you consider dust a pollutant, as I would, then yeah, dust, when it deposits on the snowpack, in the wintertime, usually it gets buried. Oftentimes we get a dust storm, it gets buried by a snowstorm. But what happens in the spring is the snow melts at the surface and the water percolates down through. And what's left at the top is all the dust layers that all collects at the top. And this makes the snow that should be fairly bright and reflect most of the sunlight back to space darker. It absorbs more sun and it accelerates the snow melt. So it has an impact on the length of the snow cover duration season and it makes it shorter. So yeah, it does have an impact on snow.
Could you comment a little bit about the drought in Utah and how bad it is and kind of what the future looks like for us and maybe in the context of population growth as well and what we need to be thinking about as citizens?
Yeah, we're still in a pretty serious drought, even though we've had a lot of precipitation in August, September, and October, because the snowpack is the most important reservoir in our part of the world. And what happens here in the wintertime is the snowpack builds up, it gets deeper and deeper and deeper, and you might have 20 to 40 inches of water stored in the high mountain snowpack. That's a lot of water. And it all gets released in 6 weeks. And so you get a huge runoff pulse, and that's what's collected in the reservoirs to a large degree. So it's good news we've had this rain because it's increased the soil moisture. And that means that our soils, when it really starts to get snowing more, they're going to be pretty close to full of water. So when the runoff pulse comes in the spring, hopefully, instead of the soils first soaking up that water, they won't. So that's a good part of it. But, we still need to have a really good snow season because the reservoirs are so low. We really do need to hope for a big year. Now, many people have probably read about Lake Mead and Lake Powell and how low they are. And, those lakes respond on even longer time scales. So if we have a really big winter, they will recover a little bit, but they're not going back up where they were 20 years ago. That requires precipitation and snowfall over an extended period. The complicating factor we have now, though, is climate change. And so that is shifting the hydroclimate in a lot of ways. More precipitation falling as rain instead of snow, for example. And that means that the runoff is less efficient. And then during the winter, there's more wintertime melt events. And our temperatures are higher in the spring and in the summer, so there's more evaporative loss. And all this means that we're shifting to what we call hot droughts, which means when it's dry, not only is the precipitation low, but it's hotter. And so the impacts of the drought are even bigger. And so that's what we're seeing in the Southwest. Most of the studies for the Southwest for the current drought show that in the absence of climate change, it would have been a moderate drought. And instead, because of the higher temperatures, it's a much more severe drought and one of the worst droughts that we can see looking back at tree rings and that sort of thing.
I think we have time for one more question, and I saved this one for last because I know this is one of your areas of expertise. What's the best way to select the correct glide wax for different snow?
I don't know anything about wax. I do a lot of skate skiing and I just go by the temperatures they tell me, and I'm not very good, so I'm not worried about going fast. So I'm not a good person to talk to about that. That's a whole art, and you need to know a lot more about snow physics than I know. So.
Okay. All right. Well, we'll end on that. So I just want to thank everybody for joining us. And, I would suggest you get connected with Jim's blog, which is a really fun blog. And also, as I mentioned earlier, Jim is part of the College of Mines and Earth Sciences, Department of Atmospheric Sciences. And folks are always welcome to come and visit us in the Sutton Building and the Browning Building on the campus of the University of Utah. So thank you for joining this event. And I'd like to give a virtual round of applause to Jim. I know we can't do that with any audible effects, but I know everybody's applauding in the background. So thanks, Jim, for your time. And that was a lot of fun. Really enjoyed it.
Thank you, Daryl.
Yeah, take care, buddy. Bye-bye.